Hello everyone, welcome to the tutorial of COA, where we are going to discuss the second part of the first module, the numbers, arithmetic operations and characters. So when we talk about numbers, the natural way of representing is ones and zeros, so it is easy for the computer to understand and also for us to form the number system in a more efficient way rather than using decimal notations. So we here on only talk about binary number representation for integers as well as arithmetic operation, that is plus, minus, into and division. So you try to understand that multiplication is repeated addition and division is repeated subtraction. So then we will go about with the introduction of representation of floating point numbers. So when we talk about floating point numbers, it is nothing but decimal notations. So if one can be further divided into much more simpler digits, that is 0.5, 0.25, 0.35 or something like that. So any number can be represented with the help of binary digit. That is, if I want to understand phi, letter phi can be represented as in 4 bits, 4-bit representation. I can denote it as 0 1 0 1. So this is my phi when it comes to binary. So how did I do this? This is nothing but 2 to the power 0, 2 to the power 1, 2 to the power 2, and this will be my signed bit. So remember that the leftmost bit is my signed bit. The rest of the 3 digits can only represent when we are talking about only 4-bit representation. So phi can be represented as 0 1 0 1. So similarly, if I want to denote a negative phi, the first sign bit will be changed from 0 to 1. So my negative phi representation, the magnitude of negative phi representation will be 1101. So it is quite easy to understand that plus phi and minus phi differs only in this particular bit. Similarly, 3 can be represented as, that is 2 to the power 0, 2 to the power 1, 2 to the power 2, and this is the signed bit. So whatever you want to increase the power, that you keep it as 1. So 2 to the power 0 is 1. So 2 to the power 0 is 1 and multiplied with 1. 2 to the power 1 is multiplied with 1. 2 to the power 2 is multiplied with 0, and the sign bit is 0. So this is what plus 3 looks like, and minus 3 magnitude will be represented as 1 0 1 1. So this is how the magnitude of plus 3 and minus 3, or as a matter of fact plus n and minus n, looks like. Alright, so let us go with a number, its magnitude, 1's complement and 2's complement. So try to understand, if I want a number, say minus 3, or we'll take it as plus 3 in the beginning. So magnitude will be 0 followed by 0 1 1. So 1's complement notation of this particular number can be represented as itself, because it is a positive number. 2's complement also can be represented as itself. So remember that For a positive number, 1's complement, magnitude and 2's complement are all the same. So if I want to show you the slide where the representation is happening, so this is what it looks like. So plus 7 can be represented as this. The magnitude is plus 7, 1's complement is plus 7 and 2's complement is plus 7. This happens for all the numbers, say 1, 2, 3, 4, 5, 6, 7 and 0, that is 8 numbers from 0 to 7 where the MSB bit is positive, that is 0. I already told you MSB bit, if it is 0, it is positive. So what interesting bit, if it is 1, it is negative. The representation is negative for a 4-bit representation. Try to understand that if I have a number, I can represent it with the signed magnitude, unsigned magnitude and complement magnitude, that is 1's complement and 2's complement. So signed magnitude is nothing but this kind of representation where the MSB bit is either 0 or 1, that is either positive or negative. If I have a unsigned magnitude, then all this representation will be 16 representations, that is I don't have to represent plus 7 and minus 7 like this. So minus 7 actually will be 15, that is from 0, 0, 0 to 1, 1, 1, which we have already discussed in basic electronics. So from 0, 0, 0 to F, that is 1, 1, 1, 1, that is 15, that is a unsigned representation. And when you're talking about signed representation, you are considering only the non-MSB bits, that is the rest of the 3 bits. The first bit, that is the MSB bit, will be taken into sign consideration. So only last 3 bits you are going to take. Okay, once that is established, any number can be represented with the signed notation and unsigned notation. So I will take into consideration 1, 0, 0, 1. So this is, if it is signed, it is nothing but the MSB is minus, that is MSB is 1, so I will take a negative sign, and this will be in fact represented as minus 1. If it is unsigned, it will be treated as 9 for 4-bit representation. So if this is clear, the rest of the concepts will be easy for you to understand. So try to analyze how it is easily done. So for one more example, if my numbers are all ones, so I will just treat it as minus 7 if it is signed. If it is unsigned, this will be 15, that is in hexadecimal what we say it is F. So if this is understood, the rest of the concepts will be easy to grasp. Alright, so this is what is all about signed and unsigned, and the same thing what we are doing with the 1's complement and 2's complement. So if I have a number, say minus 5, how are we going to write minus 5? So minus 5, I will just write an MSB 1 because it shows it is a negative number. So 5 will be 4 plus 1, so I will just write 4 plus 1. So 1, 1, 0, 1 is my 5 in binary. So magnitude will be 1, 1, 0, 1. So 1's complement of this number is simply, I am just keeping the MSB 1 because since it is a negative number, I am just keeping it as 1 itself, and rest of the bits are I am going to negate, or I am going to have a negation. I am just using a NOT gate. So I will have 0, 1, 0. So this is my 1's complement. So 1's complement added with 1 will give me 2's complement. Remember that if we add 1 to 1's complement, I will get a 2's complement. If we take 2's complement, 2's complement, we will get the original number back. So 2's complement of a 2's complement number will be always the original number. So here coming back to this 1, 0, 1 0, sorry, 1 0 1 1, I'm sorry. So 1 0 1 1, so 1 0 1 1, let me just write it here. So this is in fact minus 3. So minus 5 in decimal, sorry, in 2's complement will be minus 3, and minus 5 in 1's complement is nothing but minus 2. This is my magnitude value. I'll just show you the table. So once the table is clear with 1 or 2 values, rest of the values are as simple as that. So minus 5 is here, 1 1 0 1. So you can just go back to the figure which I've driven. You can just go back and see. So 1 1 0 1 is minus 5, and this is in fact minus 2, and this minus 3 in 2's complement. So I hope this part of the concept is clear.